NetBSD has a lot of different components, and as it grows over time, there needs to be a good way to test it. So over the years, people have had their own scripts and programs for testing things, but there was never anything consistently used throughout the operating system. So Julio said, as a NetBSD developer, I'm going to develop this framework and consistently use it for testing NetBSD. So he implemented ATF as part of Google Summer of Code, and he imported it into NetBSD. And I'm not a NetBSD developer, so NetBSD people can tell you more about that. But basically, it turned out to be a fairly good thing, and so Julio imported it into FreeBSD, which is what I'm more familiar with, and it's actually used quite heavily in FreeBSD today. So ATF was then refactored into two parts. One was a set of libraries and APIs for writing the tests, and the other was Kyua, which is a runtime engine for running the tests. And so you need to have the tests, and then you need to run them, and then when you run them, you need to gather the results from the test. And so that's why ATF is the stuff that lets you write the tests, and Kyua actually lets you run the tests and then generate reports. And so who uses Kyua? So NetBSD uses it, FreeBSD uses it, its ATF has been imported into the base system for NetBSD and FreeBSD, and companies are using it. So I didn't want to put the names of companies here without talking to them, but I can tell you the ones that I know about. In Colorado, there's a company called SpectraLogic. They have a FreeBSD-derived storage appliance. They use ATF and Kyua quite a bit. There's a big contingent of testers at EMC, the Isilon division. They use ATF. I don't know, maybe David could tell me. I think that some people at Juniper are using ATF. I am not sure, but probably like Marcel or someone would have a better idea. So it is used, and the reason why it's used is that because it's being integrated so well into FreeBSD, that if you're basing a product off FreeBSD, it's convenient to kind of leverage off of the testing framework. So how can you try it out? So if you're into FreeBSD and you have it running, it's pretty easy. So if you have FreeBSD 10 and lower, if you're used to like rebuilding your system, you put in etc make.conf with tests equals yes, and then you do all your standard make build world, make install world, all that stuff. And then at the end of that, you will have a directory called user/user/tests, and all the tests will be under that directory. So the actual ATF tests have been integrated into the build of FreeBSD. So when you build FreeBSD, you build tests, which is pretty cool, because otherwise, before that, you would have FreeBSD, you would build it, and if there were tests, they would be kind of off to the side and not integrated with the code. So once you've built FreeBSD and once you've installed it, you install Kyua. So just do package install develop Kyua or package install Kyua. And then you can go to cd user tests and do Kyua list, and that will list all the tests. And then when you want to run the test, you type Kyua test, and that will run some tests. And then once you're done, you can generate reports. And so you could type Kyua report to generate a plain report, and Kyua report HTML to generate a HTML report, and Kyua report JUnit to write out a JUnit XML report. And so I can kind of show you. don't know how visible that is, but so this is a FreeBSD 10 that I'm running on this laptop. And you'll see there's a user tests directory, and so all the tests are under here. And so if I go to, like, say, user bin, if I type Kyua list, this lists all the tests. And if I type Kyua test, this will start running the test. So you'll see pass, 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 and then one failed. And then I can do, you know, I can generate a plain text report, and then I can generate the other reports. And so the Kyua binary, it kind of works a little bit like sort of modern binaries like PKG and Git. So if you want to know more about a command, you type Kyua help test, and then it dumps out the man page for it and that kind of thing. But this is all, except for the Kyua binary, which I have to install from ports. These tests are actually built from the FreeBSD build.
If the tests and all the Kyua files are part of the base system, why isn't Kyua itself?
That's a very good question. So the thing is that I've been interacting a lot with developer Julio Merino, and so part of, like, he has some very strong opinions on how to implement software and how to implement a testing framework and stuff like that. And I agree with a lot of what he says, but I'm more pragmatic than him. So he's kind of going at it from an idealized case of, you know, what is like a pure architecture and a pure implementation, whereas I work in a company, and sometimes things are a little bit dirty, especially in QA. So I think it's good that he's implementing a good, clean solution. But to get back to your question, originally his stuff was in the base system of NetBSD. And his idea was that everything was supposed to be there. The ATF libraries for writing the test case and the reporting engine. But what he found was that if you want to work on a small piece and have your piece kind of move at a different pace than NetBSD, then you're kind of stuck. So that, but the thing is that having something in the base system is useful. So what is in the base system of FreeBSD is the ATF libraries for writing the tests. So that's how you can build the tests. But the reporting engine is in ports. And so he's been able to, like, sort of iterate at a faster pace on the reporting engine and stuff like that. So I mean, this is kind of the balancing game when you work with the BSDs. You know, should you be in ports completely? Should you be in the base system or whatever? And another project that has kind of faced this is the PKG tool. Right. So like the old package add utilities, those were all in the base system. But when Baptiste Daroussen said, I'm going to write a new package manager, he implemented all his stuff outside of FreeBSD, but then he added a little stub in FreeBSD. And so there was a lot of opposition to that from FreeBSD purists who were like, you should be in the base, blah, blah, blah. But he was able to iterate and improve PKG a lot faster than the release cycle for FreeBSD. So that's kind of the backstory behind it.
That makes sense, thank you.
Yeah. So now I'll talk a little about writing tests. So one of the reasons why I wanted to give this presentation was because I wanted to use Kyua for my own project. And so I wanted to write my own tests. But I found the documentation like really like, what the heck is going on here? And again, you know, from a purist perspective, I talked to Julio and I'm like, dude, man, this is like a barrier of entry for people to, you know, write tests, because I work with QA people. I've worked with QA people in many companies, and QA people, they don't have time to like understand the purity of your architecture. They have things to test, products to ship, And so your thing has to like kind of be easy to set up and get going. And if it's not, people are not going to use it unless they're forced to. And so that's why I decided to write some documentation so that I could use it. And then I wanted to kind of share this with the group and get feedback, and you know, so I can improve this. Because I think if more people write tests for FreeBSD, NetBSD, it helps make these things better. So what do you need to write a test for Kyua? And so you need a couple of things. You need something called a Kyua file, and a Kyua file is it's kind of like a make file, but what you can think of it, it's a file that specifies a list of tests to run. And so when I type Kyua test, Kyua, the binary, it reads this Kyua file and says, oh, okay, I know what these tests are to run, and then it goes and runs them. And so you need the Kyua file. So the Kyua file does not contain the test itself. The Kyua file is like a pointer to other programs, which are the tests. And so then you need to implement tests. And so Kyua understands 3 types of tests, which I'll talk about. There's a plain test, an ATF test, and a tap test. And so I don't know how visible this is here, but I tried to put as much stuff on one slide as I could. It's a bit hard to read, but these slides are going to be online later, so you can look at it. But basically, this is what a Kyua file looks like. And so the syntax of the Kyua file, which is a bit of a pain in the neck, is there's a language called Lua. It's a scripting language. And so in Lua, comments are not like any other scripting language.
They're like SQL.
Yeah.
A comment is delineated by two hyphens.
Or data.
So, you know, for most people who are using every other scripting language, which is common these days, that's like why, but it is what it is. So one of the first things you need is you need this thing here called syntax. And so there were different versions of the Kyua and ATF syntax. And so this thing here, you just consider it like boilerplate. This basically says everything after here is going to follow this syntax. So you put syntax 2, and that's it. You forget about it. Then the next thing you put is you invoke something called test suite, and then you give the name of the test suite. And then now you specify the tests. So this line here, it says plain test program name equals test1.sh. So this says this is going to be a test program. It's going to be called test1.sh, and it's going to be a plain test program, which I'll talk about that. And then plain test test 2, ATF program test 3, tap test, legacy test. And then the other thing that you can do inside a Kyua file is you can include other Kyua files. So that way, if you have a Kyua file, then it includes all these other ones. That's how you can get tests in other directories started from one place. And so one annoying thing, or maybe not annoying because I didn't write this thing, but I'll just say one interesting thing about this is that the test file has to be in the same directory as the Kyua file. So this Kyua file and test1.sh, test2.sh, test3.sh, it has to be in the same directory. If you try to put a different path or something, you'll actually get a syntax error and say not allowed. And the reason for this, I had a discussion with Julio about this on the mailing list, and this is something he feels very strongly about in order to kind of cleanly, you know, structure things, and which is okay. But then, which is good if you can set up something from scratch, or you know, if you have tight control of something like FreeBSD. But if you're in a real world product, I mean, I work with like products where you have like 5 different QA teams and they use different things, and you know, you need to integrate things from different people, and it's kind of hard when you kind of impose these kinds of things, but you know, that's how it is. So I said there's 3 programs that Kyua recognizes: plain test, ATF test, and tap test. So a plain test is very simple. Basically, it's a type of program that you run where if the program returns an exit status of 0, it succeeds, and non-zero means it fails, and that's it. That's the only thing that a plain test program can do. And so the entire program is a single test case. Kyua does not consider like a single program that does multiple things, multiple test cases. It's the whole program is one test case, even if it does multiple things. And so the next thing, so this is what I've been working on lately, is ATF. So ATF uses libraries, and with ATF you can only write test programs in C, C++, or Bourne shell. And so the ATF has it's a very involved API, and the API allows you to say if a test passes, fails, skipped, or if you can have a single program that executes multiple test cases, and then Kyua will recognize each individual test case. And so this is one of the things that I had a hard problem understanding how to do this, because the documentation was really I couldn't figure it out. So I don't know how visible this is, but basically this is the simplest example of an ATF test case written in shell script. So the first line here you'll see is user local bin ATF-sh. So even though this syntax for this is written in shell, you cannot invoke bin.sh directly. You have to invoke this wrapper around bin.sh. Because this wrapper, what it does is it calls a shell library, and then it invokes bin.sh. And this is kind of done to hide things and whatever. But this is something that you need to do, which is kind of different. So then to define a test case, you call a function called ATF test case, and you give it a name. So you say ATF test case test1. Then when you implement your test case, you have to implement two functions. You have to implement a head function and a body function. And so the head function it defines some metadata for the test case, and then the body is the actual thing that runs a test case. So you'll see in this in the head function, I call this other thing called ATF set. So I set this description to test1 remove file, and then in the body I remove the file. So this defines the test case. So once you've defined the test case, then you have to implement a method at the bottom called ATF init test cases, and then you put ATF add test case test1. So I could have a single script here that had test1, test2, test3, test4, test5, but I couldn't fit it on this slide. But in that case, you would have ATF test case test1, ATF test case test2, ATF test case test3. Then you would have test1 head, test2 head, test3 head, test1 body, test2 body, test3 body. Then you would have a single ATF init test cases function, and then you would do ATF add test case test1, ATF add test case test2, ATF test case add test3. So this is kind of the structure of how you have to do things. And so these are some of the things that I learned when I was doing this, is that when you're coming up with your test cases, always do Kyua list before running them, because that can tell you if there's any syntax errors in your test case before you actually run them. The other thing that I learned is that in the test case, you'll see that I don't have any exit or return statements, and you cannot put exit or return statements anywhere in your test cases. The reason for that is that the ATF wrapper around bin.sh, it calls a shell library, which actually you cannot exit prematurely, otherwise things just fall apart. And so I had to actually look at libATF.sh.subr to understand what the heck was going on. But I mean, if you follow these things and then follow this structure, it's not a bad structure to follow. You know, things look kind of clean after a while once you start doing it, but kind of getting an initial test cases, for me, going from scratch was a bit challenging. So then the next thing, which I haven't spent any time on, there's something called TAP, Test Anything Protocol. So Test Anything Protocol came out of the Perl world, and basically the output of the test is important for TAP. So TAP defines the output of the test. And if you do Kyua list, a single program in TAP, Kyua can only tell that there's a single program. It can't tell how many test cases are in the program until you run it. And so that's just kind of the limitation of TAP. So TAP, if you create a program that adheres to the TAP output specification, this is kind of what it looks like. And I don't have a sample program, but this is a sample output. So for this one, you know, you say you're running 4 tests, 1 to 4, and then OK1 means this passed, not OK2 means that failed, OK3 means the 3rd one passed, and not OK4 means the 4th one failed. And so I haven't tried this, but there are some tests in FreeBSD that adhere to this protocol, and so you can tell if they pass or fail. And so let me talk about Jenkins and how to tie all this in together. So one of the things that I did when I was at BSD Can in Ottawa in May is I worked with Julio and I said, hey, I'm using this thing called Jenkins, and it has a way of building code, and you can hook in different things to run tests. It would be really nice if your thing could hook into this. But Jenkins, it uses an output format called JUnit XML, because JUnit is a test framework that comes from the Java world. And I said, if you could make Kyua output JUnit format, I can integrate the test output directly into Jenkins. And so he actually implemented this at BSD Can. It took him about a couple of hours, but he did. So that's why the Kyua report JUnit command is new. That came about in around May, June. But basically, I've talked about Jenkins in previous presentations, so you could look online for the slides of that stuff. But basically, what Jenkins allows you to do, it monitors the SCM, like Git or Subversion, to see the new check-ins. You build the code, and then if you want, you can run tests and then produce test reports. And so Jenkins, it doesn't have a native engine for executing tests, so you plug in other ones. So a lot of people in the Java world, they use JUnit. In the Python world, there's multiple ones. There's nose and unit test and different ones. But if you can format your test output in XML with this JUnit format, then you can import it natively into Jenkins. And so if you're coming up with the Jenkins job to run Kyua, what you need to do is you call Kyua test to run the tests. Then you call Kyua report JUnit to generate the XML report. And then in Jenkins, you configure Jenkins to publish a JUnit test report. And basically, what I've been working on in the FreeBSD cluster, so in FreeBSD, I set up something called jenkins.freebsd.org. And so right now, that's building a couple of branches. So in the past, like 2 or 3 weeks, I've integrated some of this testing. So you'll see here, this job, this is a pipeline where the first thing that it does is it builds FreeBSD head. Then the next thing that it does here, this FreeBSD head package, it builds a UFS bootable image. And then this third thing here, it boots that image under Beehive. And then it calls a Kyua test to run all the tests. And then it publishes the test results. And so actually, if you go to jenkins.freebsd.org, and if you look at FreeBSD head test 2, you can see this. And so you have something that looks like this. So this is what you get when you integrate with Jenkins. So you, when you run the job, It can tell you the latest test result. If you've been running tests over time, it shows you this graph of the number of tests that have passed and failed over time. And so you can go back in history and see this. And then this breaks down the tests that were actually run. So you'll see these are the actual tests in the FreeBSD tree. So actually, I started running this like in the past 2 weeks. I found problems in FreeBSD. I found a problem in Yak of all things. There was like a uninitialized memory read in Yak, which was causing a core dump when I was running these tests. And so I was looking at the code, and then someone was telling me, yeah, I think your test framework is broken. I think this is broken. I said, all right. So I looked at Yak, I looked at the tests, I started running the tests under Valgrind. And then I emailed the maintainer of Yak, who's not a FreeBSD developer. His name is Thomas Dickey. And I said, hey, our test is failing. I ran your test under Valgrind. Valgrind told me that you're doing some uninitialized memory read. Like there's an if statement that was conditionalizing on something that was uninitialized memory. And then he looked at that, and then he started running Valgrind. He was like, oh, okay, yeah, that's actually a problem. And he supplied a fix. And that actually fixed the problem.
Oh,
so actually doing this actually helps.
Amazing. It found a real bug.
It found a real bug. So, but what I found, and I've worked in many different companies, and it's the same story. You can have tests, but if no one runs them, no one cares. And the thing is that if you don't run them regularly, they bit rot. And if you run the test like once every 6 months, but something broke it 4 months ago, then the person who broke it, maybe they don't even work in the company anymore. So the next person around, that person has no incentive to go and fix something that someone else broke 4 months ago. So for this kind of stuff to pan out, you have to run the tests all the time. And the reporting of the tests has to be so easy to follow that like anyone can go and say, oh, okay, here's the test, here's where it ran, here's the error. And so you need to have like that tight feedback and have it there really fast. So I mean, ATF and Kyua are good, but this stuff wasn't being run regularly, and it wasn't being reported in a way in which FreeBSD developers could take very seriously. So hopefully I've changed that. Now this is running like multiple times a day based on commits going into head. And so we'll see how that pans out for FreeBSD. So some other things here, the main project page for this is on GitHub. And I started writing a quick start guide for Kyua. So actually if people could look at that and provide feedback, that would be really helpful to me and other people, because I think it's really important to, whether you believe Kyua is good or not, or you have a better framework or whatever, I mean, FreeBSD has bought into this. So rather than argue about it, let's help make it better. And so there's a mailing list, FreeBSD testing at freebsd.org, and Kyua discuss, which are good ones to show. And I guess the last thing that I can do, if this works, is I can show so this is a job that I have. This is running on my laptop. This is Jenkins running on my laptop. So you'll see so I set up this job called test. And basically, all it does is the following. It goes to CD user test local Kyua integration, and it runs Kyua test, and then it does a Kyua report JUnit, and it writes out the XML file somewhere. And then this is the post-build action, publish JUnit test result report. And so this is the test result. And so basically, if you do that, you can build this. And as it's building, you can look at the console output, and you'll see this is the console output. It's actually running the test here. As you see, pass, 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 pass. Maybe some failures, but it looks like it's pretty much passing. And so it ran the tests, and then now it generated the report. And so if I go back here, I can click on test result, and so you'll see I can drill down into and so these are the tests that ran, and I can drill down some more. You'll see the status passed. It tells you the duration, how long it took each test to run, and then you can see like the standard output, standard error for the tests, and so this is very handy. Before this JUnit integration, Kyua, it generated its own HTML, and it still has that. So the HTML looks like this, which is, it's not bad, but it's kind of very simple. So the Jenkins thing, if you write out that XML file, Jenkins gives you all this for free, and it's pretty sophisticated. So basically, that's pretty much all I had to talk about. So any questions? Yeah.
Can I ask you that 3-node thing you were showing earlier? So you're saying
Yeah.
that anytime something's checked into the FreeBSD source, that you're building the source and then creating a bootable media, and then loading that into a Beehive virtual machine and running tests against it?
Yeah.
How often does this happen?
All the time.
That seems
Continuous integration. Yeah.
nice. That's awesome.
Because it's like what I said, like I've worked in big companies. Like I worked at a company that is familiar to someone sitting over there, and I saw tests that were written like 15 years ago, and they were awesome, but they were 15-year-old tests. And so what happened was that company kind of went through a downturn, and so they're like, well, we don't have enough people to like maintain these tests, so let's kind of leave them off to the side. And so the tests bit rotted, and then 5 years later, someone said, oh, we have all these tests, let's try running them. And then the tests were like totally busted, and so it was like, well, should we put resources into fixing these tests, or should we put resources into banging out new features, dealing with customer issues, selling more product? And of course, who wins in that argument? So I'm hoping that this thing can kind of have some life in FreeBSD, because the reason why I like to do these kinds of things is that it helps FreeBSD, but then I learn a lot by doing this, and I apply it to the jobs and stuff that I work at, and I hope that by doing this kind of stuff and putting documentation online, doing presentations, hopefully people who are in companies can say, hey, this is a good way of doing things, and this is an example, and learn from that. So, because otherwise, I don't want to do things like how, hey, let's write things that bit rot after 15 years. That's pretty lame. So, anything else?
All right, that's great. Good job.